So we have to perform our fourth experiment, that is to study the various clipping and the clamping circuits. As you know, I have listed here all the experiments which we are going to do in our lab course. So we are already done with the PN junction diode, the input and the output waveform of the half wave rectifier, the full wave rectifier, using the center tap transformer and the bridge rectifier. So the next experiment which we'll study is that we'll be studying the output waveforms, obviously with respect to the input waveform applied, of the various clipper circuits. So again, we'll go for the aim of the experiment. The marker is okay. The aim is to study various clipper circuits and observe the output waveforms. Okay, I'm sure that you have studied these clippers and the clampers in your theory course. So I'll just briefly tell you the overall classification of the clippers. So it is simply like these clippers can be classified as, or they can be divided into the positive clippers, or they can be divided into the negative. So they are categorized as positive or the negative clippers. Now here, positive clipper is is a circuit which clips the positive half of the circuit, and the negative clipper is a circuit which clips the negative half of the circuit. And further, these clippers are classified as the series and the shunt clippers. Series and shunt, depending upon the connection of the diode in the circuit. So if the diode is in series with the circuit, it's a series clipper. If the diode is in shunt with the circuit, it's a shunt clipper. So what we can have positive clipping, negative clipping, series clipper, shunt clipper. And besides this, we can add a DC source into the circuit, which will clip the output waveform either above or below, and that battery source which we are using into our circuit is known as the reference voltage. So depending upon the orientation of the diode and the connection of the orientation of the diode with respect to the input and the reference voltage, we can have clipping above or clipping below the reference level. I'll quickly be drawing these circuits one by one so that we can then simulate these circuits in our easy EDA. So first circuit I'm drawing, let me use the ruler. Okay, so it is we have a diode, like we have a space for the diode, then we have space for a resistor, and we have a circuit like this. Okay. Okay, so let's make a circuit like this. So here we have a diode, here we have a resistor like this, a simple circuit where at the input we are applying the V in, which is the AC source. So we can, make it like this, connect it like this into the circuit, and here is the output waveform. And let us say that the V input is a sinusoidal source. So this is the diode D1. Now the diode D1 will be forward biased during the positive half cycle, and it will be negative reverse biased during the negative half cycle. So this will be a negative clipper, because the output waveform corresponding to the input waveform, if the input is like this, where Vm is the peak voltage and here it is you have the minus Vm, then corresponding to this input waveform, the output will be, that is, it will conduct only during positive half cycle, it will conduct only the positive half cycle. So the negative side is clipped off. So this one is a series negative clipper or negative series clipper. That's one and the same thing. Okay, and similarly, if we change the orientation of the diode, that is, we connect the N side of the diode to the the voltage source, it will be a series positive clipper. The positive half will be clipped off. Now similarly, let us see about the shunt clipper. We take a resistor here like this. Now the diode is to be connected into the shunt like this. This is a load resistor R. Say this is RL. V in, same sinusoidal source to be applied. R1 is the input resistor. This D1 is the diode. And V out is the voltage waveform which is to be observed at the output. Now, corresponding to the same input waveform, the output would be like what? Because you know that the diode D1 will be forward biased when the the V in is during the positive half cycle of the V in, and it will be reverse biased during the negative, because this P side will be connected to the upper terminal. Now here V out, what is the voltage which will appear at the V out? The voltage which will appear at the V out will be the voltage which will appear across the diode. Now when the diode is forward biased, this portion is complete. Okay, the diode is conducting, it is forward biased. So V out will be simply the drop across the diode. And when the diode is reverse biased, this becomes open and V in will directly appear across the V out. So that is known as the positive shunt clipper. So it will be corresponding to this. So positive it will conduct and negative it will not conduct. So negative half cycles will appear across the output. So this is known as positive shunt clipper. Okay, so this is positive shunt clipper. Negative shunt clipper would be that if we change the orientation of the diode, change the P and the N sides, we'll get the negative shunt clipper. Now similarly, we may have we may add a battery source into our circuit, and the circuit to be drawn will appear like this. Let us now apply some biasing to it. Let us take the case of a shunt clipper first. So at the input you have a resistor. Assume that I'm taking the sinusoidal input voltage in all the circuits. That's why I'll not be drawing them again, and then we'll be using them into the circuit. Now this one, let us say diode is connected like this, so it is a negative shunt clipper now. And with this negative shunt clipper, you have a voltage source where the negative part of the battery or the DC source is connected to the P side of the diode. And then you have at the output a load resistor RL. Okay, and this is your V out. Here you have V in, and this one is R1, and this one is diode D1, and this is the reference voltage VR. Okay, VR can be adjusted to any value. Okay, now this one, obviously it will be a negative shunt clipper, because if we change the orientation here, it will be negative shunt clipper. But is it above the reference or is it below the reference? We need to check that whether it is above or whether it is below. So you can see that this diode D1 will be forward biased only when the V in is negative. So when V in is negative, D1 will be forward biased, the circuit will be closed, and V out will be simply equivalent to VR during the negative half cycle. And when the V in turns out to be positive, diode will be reverse biased. This will become open, so there is no connection of the battery. So V out will be directly linked to V in. So V in will appear at V out, and the output waveform will appear like this. So it means that the positive cycles will be conducted, and depending upon the value of the VR, during the negative half cycles, VR will appear, and then we'll have again something like this. So this one is clipping, this is clipping below the reference voltage. Let us say the value of the reference voltage is here and Vm is here. Now let's change so this is the negative clipper, because the negative half is being clipped off. Negative clipping above VR. Okay, and now let's take up another waveform, another circuit. By changing just the orientation of the diode as well as the battery, we can do many combinations by either changing the diode orientation or changing the battery orientation, or by changing both. So in a total we'll have the 4 combinations for the shunt clipper, and similarly for the series clipper as well. So you have a resistor here. Change the orientation of the diode now, so it is like P connected. Change the orientation of the battery now, it is like this one. Okay, so this is your diode D1, this is the input resistor R1, and across the output terminals you have the output resistor RL. This is your battery VR reference voltage. It can have any value set by us in the circuit, and this is the input sinusoidal voltage waveform. Now just check. V in will forward bias the diode during the positive half cycle of the diode, whereas the battery will reverse bias the diode. Okay. Now this V out will be equal to, I can just write it, V out will be equal, in case of the shunt clipper, V out will be equivalent to VR when D1 is forward biased, and V out is equivalent to V in when the diode D1 is reverse biased, because during the forward bias the circuit will be closed and during the reverse bias circuit will be open. So there is no point that the battery voltage will appear across the output voltage waveform, whereas the input voltage is the voltage parameter which will be appearing across the output voltage, which will appear at the output. Now see, V out will be equivalent to this V reference only during the positive half cycle, when it will be reverse bias. So the output waveform will be like this. Suppose VR has some value, so during the positive half cycle the V out will be equivalent to some V reference which is here, and during the negative half cycle the diode is reverse biased and V out will directly follow the V in, so it will be like this. So this is known as clipping above VR. Clipping above VR. But remember, this one is the positive. This is negative clipping. no, this one, sorry, this is not the above, this is the below, because V reference, all the waveform which is below the V reference value has been clipped off, and the reverse is for this very kind of a circuit. So similarly, we can make many other you see waveforms like this, taking any combinations. Now I'll show you many other circuits, like in the now for the series orientation of the diode, that is the series clipper. So we'll be implementing then all these circuits. Let us take a reference voltage here, let us take a diode here like this, and you have a load resistor here like this, and this is the battery source or the V reference, positive and negative. This is your diode D1, and this one is the load resistor RL. And V in obviously sinusoidal, and V out you have to see what is it. Now here the case is a bit different. Here in this kind of a circuit, when the diode is in series connection with the battery, we have to compare the magnitudes of the two voltage sources, which are the V in and V reference. Okay. Now, you can see that the negative terminal of the battery is connected to the diode D1. So, this battery also forward biases the diode. Okay. Whereas V in during the positive half cycle will reverse bias the diode. Okay. Now, as V in starts from 0, but VR has already some value. So, until and unless V in becomes greater in magnitude than VR, diode D1 will be forward biased during the positive half cycle, and it will reverse bias only when V in becomes greater than VR during the positive half cycle. Whereas during the negative half cycle, diode D1 is simply going to conduct. Now, here what will be the waveform which will appear across the output terminals? The voltage waveform which will appear across the output terminals will be shown here. So let us say this is your V out, and okay, now for the period where V in is less than VR, the diode D1 is forward biased, because VR forward biases the diode D1, and V out will follow your V in. Now, when V in becomes greater in magnitude than the your this when V in becomes greater in magnitude than the reference voltage, then obviously during the positive half cycle, then obviously the your diode becomes reverse biased. Your diode becomes reverse biased, and this circuit becomes open. When it becomes open, then V out will be simply equal to the V in. So for that period it will remain as V in like this. And then when V in turns out to be negative, this diode even conducts, and the output will follow the waveform like this. All right. Yeah. Now another circuit can be, we change the orientation like this. We change the orientation of the diode now. Now the opposite is going to happen. Depending upon the value of the V reference, we will have the output voltage waveform. So this is V reference VR, this is your diode D1, and this is the resistor RL. Now we can see that V reference forward biases the diode D1, and the positive half cycle, this will be forward biased, and So during the positive half cycle, it will conduct, and during the negative half cycle, the diode will be reverse biased, and the negative half cycle will not appear. However, we can apply the KVL over here, and we can find out, depending upon the polarities of the two voltage sources, we can find out what is the value of the voltage for the series one. Then let us add a voltage source to the diode in the shunt with the resistor. Let's keep the diode in the series only, and let's add a voltage source. So the diode is here only, and let us take a reference, take a resistor and a reference voltage like this. So this is the V out, plus and minus. So you can see, based upon the orientation of the diode, this V reference is reverse biasing the diode, and V out will be equal to V in only when V out will be equivalent to V in when V out will be equivalent to V in when the diode is conducting, and V out will be equivalent to VR when the diode is not conducting, and the output waveform will look like this. So if you have a input waveform like this, your output voltage waveform will be somewhat like, depending upon the value of V, your waveform output will be like this. Okay, so this means that during the positive half cycle, you have two voltages. So when V in is lesser than VR, your diode will be reverse biased, and V out will be equivalent to VR only. And then when it becomes greater than the VR, diode becomes forward biased, and V out follows V in. And the same happens when V in falls below VR. So this all might have been explained to you in your class. Okay, now let's just go to, so the trick is to remember, while you're doing the theory, the trick is to remember that you need to compare the magnitude of the two voltages whenever the diode is in series. Whenever the diode is in series, so that's important. And obviously the reverse of this will happen if you change the orientation of the diode. And another circuit can be, take a resistor, take another load resistor like sorry, not here. Take a resistor, and then take a diode, and take a voltage source like this. Ground is important, okay? So this one is your reference voltage, and this one is your R1, and this is your V out. Okay, same input sinusoidal you're giving to it, and the output waveform will be, how will the output waveform look like for the shunt? If you have, okay, so if you have a sinusoidal input waveform like this, corresponding to this waveform, let us see what will be the output voltage waveform. So during the positive half cycle of the input, the diode will be reverse biased, and the V reference will appear across V out. But this is not going to happen for the entire value of the positive half cycle, because VR has a fixed value. For example, it is 3 volts, and your VM has a value, peak value, that is 5 volts. So this 3 volts is forward biasing the diode, but the peak value, that is 5 volts, or during the positive half cycle, it is reverse biasing the diode. So until and unless this input waveform reaches the 3 volts, your diode is still forward biased, and your V out is equal to the value of VR. It is that point up to which the diode is forward biased. Now when V in becomes greater than VR, it is this portion. When V in is greater than VR, that means now 4 volts is greater than 3 volts. So obviously this battery will not be able to still forward bias the Diode. Now what is going to happen is that this diode will become reverse biased and the circuit will become open, and V out will follow your V in, and the same is going to appear up to the point where V in becomes lesser than VR. It becomes constant and like this and this. So this is known as clipping below the reference voltage. That is for the shunt. Now obviously the reverse will happen if you change the orientation of the diode and you change the orientation of the battery. Same thing is going to happen. Another circuit which is important in the clipper circuits is the combination clipper. So in which half part of the positive wave is clipped off, and some part of the negative waveform is clipped off. So you have you have a resistor, you have a diode like this, you have a battery which is connected here, then you have another diode. These two diodes have the opposite orientation, and then you will have another battery. So you have to use, in this type of a circuit, you have to use two reference voltages, VR1, VR2. However, the input is the same, that is V in, and this is R1. So this is diode D1 and this is diode D2, and here you'll have the V out. Your V out will appear like corresponding to the input, which is your this waveform. Your output will be like this, that is it will clip off, then this and this. So this part will be because of the diode D1, and the negative part will be because of the diode D2, or this value will be equivalent to VR1, or this value will be VR2. So these are the various clipper circuits which we will now be implementing in our easy EDA environment in my next video.